let's talk about some of the things. One of the things that struck me in looking at the material you sent me this morning was really kind of a couple of innovations. The first one being a 5-phase motor as opposed to most motors being 3-phase. And I'd like you to help me understand that a little bit better. And then also you've got a liquid motor, which is the first that I'm aware of, at least. So tell us a little bit about those.
Yeah, so I actually have got a, let me grab here. I don't know whether you can see this.
Okay, yep.
This is the, we call it HX Cool.
Okay.
So this is a project which essentially fell in our lap. We had a customer who was hauling almost 250 kilograms of weight, and they tried all kind of motors, and every motor failed. You try the geared motors and the gears fail. You try a bottom bracket motors and you have got a ton of maintenance cost every month in terms of repairing the parts. And so they really needed a brushless, gearless system, but then their brushless, gearless systems obviously overheat, right? That's something which we know that they can go fast, but they overheat, right? So they liked the fact that we have a 5-year warranty. And they said, well, we like to use your motor, but we want to be able to use it to haul 250 kilograms, 500 pounds of cargo. Right. So what we did was we did a lot of research and development, 2 years, and figured out a way to be able to have a liquid cooled system. So it allows the motor not to overheat and still carry 500 pounds of weight all day long. Right. So this looks like our normal motor. This we call a platform 3.0, or this is actually a 750 watt platform. It's fully sealed. It is fully sealed, and we have filed a few patents on the things we had to do in order to make this possible. So this one essentially allows you. There is a special liquid inside in this one, and that allows to keep all the electronics are inside. So the electronics, all the electromagnetic windings, components, magnets remain fairly cool. And that was took us a long time. The liquid cooling, people have experimented with it quite a bit. But the trick was, how do you make it, sustainable, make it reliable? So you won't know a difference between a regular hub motor and this motor.
So just so I understand here correctly, now there's no tubing coming out of that runs to a radiator, that type of thing. It's all enclosed, but there is enough liquid thermal mass, for want of a better description, to help dissipate the heat inside of that, so that the heat doesn't build up in a particular area and cause the motor to stall or short out.
Yeah, I mean, well, we have got the thermal derating inside the motor, so our motor's never really shut down. Right? So there is always a thermal derating inside the motor. Here we had to develop a special liquid. You can't use a liquid. I can't take a glycol and put it in there and say, okay, that's one of the liquids used in liquid cooling. I cannot do that, right? So we developed a special liquid which allowed us to maintain certain temperature, certain pressure inside the motor. We also developed certain seals. The seals are very important. So we developed all of that engineering, all that. Part of it we had to figure out how to perfectly seal the motor and how to have a perfect balance of temperature and pressure inside, and that had to be done with a particular kind of a liquid. Right. So that's the part of the invention we have here.
So this motor that I'm looking at now, 750 watts, is capable of pulling a total of 500 pounds in, 200 and some
50 kilograms.
250 kilograms. Does that include the bike and the rider, or is that just the cargo? I mean, how does that?
That's just the cargo. So if you add, that's just the cargo.
So I could see this being on some type of a obviously cargo bike, right?
Yes. So this is being used on a cargo bike. We actually have got very cool applications of these motors. We have, recently we did an application where it's being used on a go-kart where you're hauling a family of four.
Oh, okay.
Right, so there they have the same issue that you have got problems in terms of motors. Geared motors fail. Right off the bat, the gears essentially crumble inside the motor, and then you can't use the mid drive motor because they cause terrible havoc in terms of maintenance cost. You have to go to a bike shop almost every week, every month. So this solution becomes, very elegant that you say, well, this is the solution in terms of supporting that kind of application where you have to have a lot of cargo.
Right. Okay. So you've got a 750 watt. What others do you have?
Well, we have got our most prominent platforms are 750 watt, and then I have got also the 500 watt.
Oh, okay.
Yeah, so this one is a thinner platform. It's great for bicycles, and we have got really great performance out of these. So we have 500 watt, and then we have the third platform, which is 1,000 watt, which is bigger than the two. Essentially, this we call it 1.0 because it has got a very smaller stack.
Right.
And we have got 2.0 and 3.0.
Right. So actually, a lot of these e-bikes you see, particularly in Europe, aren't any more than about 200, 250 watts. Do you have anything in that class, or are you sticking primarily to 500 watts and above then?
Well, we essentially what we do is we typically derate our 500 watt platform and a 750 watt platform to 250 watt.
Oh, okay.
In the European regulation. So we use the same thing. For example, this HX Cool, essentially people still want to have the torque. And people still want to be able to have, get away from the maintenance cost of mid drives and get away from the gears. Okay. So still the platform we use in Europe to be able to supply the right solution.
Okay, good. Now also you've got this. You're not only doing the battery; it's actually a complete system. So you've got the motor. I see one of the looks like a battery that mounts on the frame.
Yes.
Yeah, that would be the rack mount there.
Yeah, we have a rack mount battery. We have got the down tube battery here, right. Which is one of our very popular models, and then we have got this one here, 48 volt system.
So help me understand. Almost all when this all started back when we were looking at basically 24 volts. Then eventually we gradually evolved to where I think most of the bikes now are 36 volts. Now we're starting to see 48 volt. Why are we looking at more torque? Are we looking at higher speeds? What's the advantage of the one over the other?
Well, I think it's really driven by the deficiency of battery technology.
Okay.
So as I go higher up in the voltage, I reduce my burden on the cells. Right? So as I reduce my burden on the cells, I'm able to have longer life of the battery.
Ah, okay.
Right? So it's more driven by the fact that, the battery technology is still, I think, in the dark ages when it comes to us enjoying, people like Elon Musk are pushing the envelope. But still, battery technology is in the dark ages when it comes to fulfilling the human needs today.
Yeah.
And so all these progressions, we are making incremental improvements in terms of the battery technology, waiting for a major breakthrough to happen. So 24 volt to 36 volt to 48 volt, it really lowers the burden on the cells.
Okay.
In order to, and then of course, with the 48 volt, it allows you to get more speed and more power as well. You can, but that's something which can be designed even for 24 volt or 36 volt as well.
Right. Well, one of the things and as you know, I'm developing this modularized rental system for electric bicycles called a Quick Bike. And one of the things, obviously, I want to be able to do is charge those with solar energy. So, in talking to some of the solar people that I know, they asked me, well, what's the voltage of the battery we're going to be charging? I said, well, it's 36. And they say, dang, solar is perfect for 12 volts, 24 volts, and 48 volts, but it's not good for 36 volts. So maybe I need to be talking to you about that 48 volt then.
Yeah, yeah. There you go. I mean, 24 volt is also available. For if you want to have a 24 volt battery, that's easily available. But yes, I mean, the market has slowly trended towards 48 volt simply because it allows the batteries to last much longer.
Right. Okay. So does that also translate then into, if I go 48 volts, do I get more range, or is that a function of the number of cells in the battery and that type of thing?
Yeah, so the watt hour really decides how much you have in your tank.
Right.
But the efficiency of watt hours, if you draw the current, small amount of current, then the efficiency of watt hour is much higher. So for example, this battery here actually is 550 watt hours.
Right.
Right? So if I draw 5 amps of current out of it, right, that 550 watt hours will be delivered at much higher efficiency than if I draw 10 amps of current out of it.
Ah, okay.
Right? So obviously that allows us to make, so with the 48 volt, it allows us to have, better efficiency of the tank capacity inside, the battery.
Okay, good. Now let's talk about 5-phase versus 3-phase. What's the advantage of 5-phase, and what is 5-phase as opposed to 3-phase?
Well, see, so what we have, what we have shown today is that the 5-phase can deliver 40% more power than a 3-phase system, right? And that is a proven fact. And also we can deliver that power much more smoothly. It can also, we have got not only the power delivery, but also the feeling of the motor. Motor has got no resistance, right? So it allows you, people can make a claim that, okay, we can make a 3-phase motor do this, this, and this, but 5-phase have got natural benefits. Right, so natural benefits which fall out of a 5-phase is the fact that you have got much vigorous power delivery, much more vigorous power delivery out of a 5-phase system. Given the same, if I take the exact same motors, right? If I take the exact same motor, they have the same weight, they have the same whatever. You can decide whatever parameters you have. Exactly 2 identical motors. One, if I make it 3-phase, and when I make 5-phase, I have 40% more power delivery than a 3-phase. So, and I have got better efficiency of the motor. So when you are beginning to look at bikes which travel at 45 kilometers per hour, you have a hell of a better efficiency than you have with 3-phase motors.
Okay, so what internally is different then? Is there just more windings? The electronic sequencing is different. What's different between the one phase and the other?
So the motor, essentially, we have got in our particular motor, we have got the electronics are more complex, essentially, because you have got more switches. But it allows you to distribute the current. Normally, you distribute the current over 3 phases. Right, so when you distribute the current over 3 phases, you have more resistance of the winding to deal with. And when you distribute the same current over 5 phases, you basically are able to have much lower resistance of the winding, allowing you to have better efficiency. And you also have got, if you can think about that, there's a pushback from a direct drive motor, the pushback, which you call it back EMF, right? So the pushback from a 3-phase motor is much stronger, curtailing off the power, whereas the 5-phase pushback is much less. So you can actually deliver the power for a much longer speed range than you can for a 3-phase motor.
Okay.